Solving a three-variable system of equations in many ways is very, very similar to solving a two-variable. It is a longer process because there's more going on. But for the most part, it's a lot of the same things. Now, when it comes to systems of equations, it is impossible to solve a system of equations that has more variables than its number of equations. If it's a three-variable system, at minimum you need 3 equations. If we wanted to do a 5-variable system, we would need 5 equations. We are not getting to 5-variable systems. That's a little intense. We're going to stick with 3-variable systems. I'm just going to zoom in a little bit, make sure everyone's got that down. Put the laptop away, please. Thank you. Okay, now when it comes to solving a 3-variable system, generally what your goal is to take that 3-variable system and manipulate it so that it becomes a 2-variable system. That's your goal. The way that you do this is you start by eliminating some variables. I love when redirected behavior just requires us looking at people. Okay, so the way that we take a 3-variable system and change it into a 2-variable system is we start eliminating variables. So we're going to start by taking 2 of the equations. It does not matter which 2 equations you work with, and you are going to eliminate one of the variables. Once you do that, you're going to get an equation in 2 variables, you're going to set it aside, and you're going to repeat the process with a different pair of equations, eliminating the same variable. Now, because of the fact that the first thing we're going to have to do is eliminate the same variable twice, the first thing I recommend you do when you look at these problems is look at the numbers in front of them and ask yourself, which of these would be the easiest to get to cancel out in 2 different ways? So, if I were to start by looking at x's, none of them are the same digit. I can multiply 2 by 2 to get it to turn into 4 pretty easily, right? But there's not an easy second pairing. If I paired up 3 and 4, I'd have to multiply both equations. If I pair up 2 and 3, I'd have to multiply both equations. Y's is the easiest option because I wouldn't have to multiply anything. There's 2 pairings where the y's have opposite coefficients. Now, say that wasn't true. Say the y's looked kind of like the x's. The z's aren't a bad option either because I can pair the first equation up with the second and only have to multiply one equation. And then I can pair up the first with the third. But making a game plan on which variable you're getting rid of is going to save you a heck of a lot of work. In this case, the y's are the easiest. Now, for the sake of ease in keeping track of what's what, one of the things that I often do, which is not a requirement, is I number my equations. Particularly, I do this when I do my notes. I'll be honest, when I'm doing the problems myself, I don't do it. But I number them so it helps me keep track of which equations I was working with. And I do it in different colors to kind of help me keep track a little bit further. Now in this case, we established y would be the easiest to work with. I'm going to make 2 pairings with y. Since I have only one negative, the easiest pairings are going to be pairing up 1 and 2, and then pairing up 2 and 3. So, I take equation 1, and I take equation 2. Because of the fact that they already have that opposite coefficient on y, I can go directly to the adding. 3x plus 2x, 5x, y plus negative y,
0.
Cancels, that's the point, it goes to 0. Negative z plus 2z,
Z.
positive z, equals negative 6 plus 8, 2. That equation, I am just setting to the side for now. That equation, I do also tend to number. Okay, I need to keep that equation, but I'm not dealing with it for a second. Okay, I make another pairing. Again, the easiest way then is for me to pair up 2 and 3 next. So equation 2, which is 2x minus y plus 2z equals 8. And the third equation. 4x plus y minus 3z is equal to negative 21. Since the y's already have opposite coefficients, I can go directly to adding. Now, I am going to emphasize, you need to eliminate the same variable in this step and this step. If you eliminate different variables, you've just given yourself an impossible problem. Six x minus z equals negative 13. For the sake of my notes, again, I number them at this point. That is equation 5. You get 5 equations that I go through and I put the numbers on when I do this process. Once I have these 2 equations, at 5x plus z equals 2 in this case, and the 6x minus z equals negative 13. Now, I do what we did yesterday. There is a way to solve a system of equations in 3 variables by substitution, by the way. It doesn't work out nicely most of the time. There's very rare situations where that's the best way to approach. Elimination tends to be the best way. So, now I've got this. Things should be stacked appropriately. We're good there. Do I have opposite coefficients anywhere? Five and 6 are not opposites, but are 1 and negative 1? Yes, if I didn't have opposites, then I would get opposites by multiplying. This case, it worked out nicely. So I can go directly to adding. 11x equals negative 11. X is negative 1. Ask the same thing like I asked yesterday. Once I find the first variable, am I done? No. How many variables do I need? 3. The answer to a system of equations in 3 variables is a ordered triple. It is a coordinate point in the 3-dimensional plane where they're all intersecting. Generally speaking, it will be x, y, z. If it's not x's, y's, and z's, it goes alphabetical order. Okay. Once I have x, imagine all we had to start with was this. Once you'd have x, how would you have found z? Plug it in. That's what you're going to do. Doesn't matter if it's in equation 4 or equation 5. Just make a choice. I'm going to choose equation 4. Negative 5 plus z equals 2. Add 5 and z is 7. I have x, I have z, I still need y. Once you have two of the variables solved for, plug back into one of the three originals to solve for the third variable. Again, it doesn't matter which of the three originals, just make a choice. I'll do the first one just because I can. 3 times negative 1 plus y minus 7 equals negative 6. That is negative 3 plus y minus 7 equals negative 6. That is y minus 10 equals negative 6, so y is equal to 4. Do make sure you're plugging into the correct variable. You don't want to plug y in for x or anything like that. Final answer is an ordered triple. X, y, z. These ones do a lot of the same things. These ones are just more tedious. They're a longer process because there's more variables to solve for. I've got just one more example for y'all today. Just pausing because I still see a couple people writing. Now, I'll be honest with you. That first one, while long, is probably the easiest that most of them get. It's not the absolute easiest, they're slightly easier, but you'll notice that we didn't have any issues with opposite coefficients popping up on the last one. I didn't have to multiply anything in those problems. That's not realistic on what's going to happen very often. Oftentimes you're going to have to do some multiplication. Can you all multiply? Especially if I let you use a calculator, can you multiply? If you cannot multiply with a calculator, I'm concerned we might need to send you back to elementary school. No? Okay. You can multiply. Okay. Do I have as nice of a setup here? No. I need to make a game plan before I jump in. Are x's easy to eliminate twice? Y's easy to eliminate twice? Or z's? The z's are going to be your easiest bet. Because while the x's, I'm going to have to multiply both things regardless of which two I pick. The y's, I could make one pairing nice, but not another. The z's, the moment you see a 1 or a negative 1 as a coefficient, beautiful. So, that second equation especially is key here. Now, again, not required, but I number things. Helps me keep track of what's what. Do you have to? No. Okay. So, I'm going to start with working with equation 1 and equation 2. Now, as I do this, to save myself a little bit of writing, I jump directly to doing the multiplication if I need to. Which equation am I going to multiply by something?
2.
The second one. And what am I going to multiply it by? 2. 2 or negative 2? 2. Be careful. Remember, you want one positive, one negative. So that means, since I'm going to multiply the second equation by something, when I write the first equation down, I'm just going to straight up write it down, making sure I copy the right numbers. But when I write the second one down, I'm going to write down its version where I multiplied 2 by it. And I tend to write this here. That way, if I've made a mistake, I can go back and double check where I screwed up. And I don't have to ask myself, wait, which equation was it? What did I multiply it by? It tells me. Again, not required, but it helps. 2 times this, negative 4x. 2 times this, positive 8y. 2 times this, negative 2z. Do not forget to also do 2 times the constant. Now what?
Add it together.
Add them. What is 5x plus negative 4x?
X.
What is negative 3 plus 8? Positive 5. Why? Those cancel out. If they don't cancel out, you did something wrong. Equals negative 4. Here's where people tend to get stuck. What comes next?
Y, 5y.
Take another 2 equations and do this thing again. So often, we are so used to, in math, you do something and then you continue to work with that indefinitely. Sometimes you have to do something to get partway through, and then you have to skip and go partway through to bring things together. You go back to your originals and pick another 2 equations. I worked with 1 and 2. Should I work with 1 and 3 or 2 and 3? 2 and 3. Why? Because I only have to multiply one of them. And what variable am I trying to eliminate? What did I eliminate over here? The z disappeared, so I'm eliminating the z again. Which equation am I multiplying by what? Three times equation 2. So 3 times that is negative 6x. 3 times that is 12y. 3 times that is negative 3z. And do not forget to multiply the constant. Do I have to multiply anything by equation 3? No. That's why I liked the z's. Now, add them. Get that z to eliminate. You multiplied so that it would. Now do it. Negative 6 plus negative 3. Negative 9x. Be careful with your positives and negatives. 12 plus negative 2 is positive 10. Z's cancel out. Negative 33 plus 14, negative 19. Two pairs, eliminate the same equation, same variable, I should say, twice. Get your equation 4 and your equation 5. I now have two equations that work in x and y. Which means now I can work with them together. And I'm back to doing elimination. Could I do substitution with two variables if I really wanted? Yes. Is it more work? In my opinion, yes. How do I get a variable to eliminate within those two? Top one by 2, -2, or the top one by 9, depending on which variable you're trying to eliminate. We said 2 first, so I'm going to do that, but make sure you make it negative. So I get -2x minus 10y equals +8. And now I can add. -11x cancels equals -11. X is 1. Once you have one variable, how do you find the second? Plug it in where? One of the two variables. Don't go all the way back to the 3 variables yet. One of the 2 variable equations. I don't care if it's question 4 or equation 4 or equation 5 or the modified equation 4. Just pick one. I like the first one. y equals -5, so y is -1. Once I have 2 variables, now I go back to one of the originals. Doesn't matter which one. Make a choice. I'm going to choose the first one. 5 times x minus 3 times y. Make sure you're plugging back into the right variable. Plus 2z equals 18. 5 plus 3 plus 2z is 18. That's 8. Y'all know this part. 2z is 10, z is 5. Am I finally done with this problem? Put your final answer, but otherwise, for the most part. Now, keep in mind that there might be some times where all of a sudden you go and you work with 2 equations and you get something like 0 equals 0. If you get 0 equals 0, what's that mean?
Infinite solutions.
Infinite solutions. What if you go through the process and you get 5 equals 0?
No solution.
There you go. Okay, today's assignment is a book assignment.